So what we've got to work out then is the probability of getting our observed result, which was 11, or better than that, so 11 or more. We want the probability of getting 11 or more. Now, if I'm writing this down, I really ought to have stated somewhere already what x actually is. So x is the number of patients cured. And I also need to state what distribution I'm using. Well, we talked about it earlier. We said x then will follow the binomial distribution. We said earlier n is 20. And under the conditions of the null hypothesis, which is what we use, p is 2/5. Right, how would you go about working out the probability x is greater than or equal to 11 from the binomial distribution here?
1 minus x is smaller than 11.
1 minus the probability that x is smaller than 11. Yes, smaller than 11 is true. The tables always have less than or equal to, so 10, which is exactly what you said. Less than 11 is the same as less than or equal to 10. So reach for your tables. Do your tables have n is 20 in them? If you do, tables do have n is 20 in them for binomial. Do they have p is 2/5 in them? Well, I've chopped the corner off my tables. Oh, and I do. No, it does have plenty. I reckon it's on page 13. N is 20 is page 13, and 2/5 is 0.4. That's there, and I can read off a probability for 10 of being 0.8725. So I would do 1 minus that. So I just got that straight from my tables.
Sorry, so what's the formula?
Yes, there's one on the table up here. Okay, can I go back there because I don't? It might be there for a reason. It's not in my room. So I have this here. Well, that's 12.75%. That decimal. So if we go back to what's at the very top of the board, is that probability less than 5% or greater than or equal to 5%? Greater than or equal to 5%. So I'm going to accept H0. It's not such a rare event. If the old medicine would have come up with that number of people, or better than that number of people cured, 12%, 13% at the time anyway. So there's no actual evidence that the new medicine is any better. So we can say then, at the 5% significance level, there is no evidence which will lead us to reject, no evidence to reject H0. So we therefore have to accept H0, and H0 then was the new drug is no better.
In reality, would you then do the test again and again, so you're consistently getting?
I mean, yes, you could do. I mean, you could obviously the larger sample. Yes, the larger sample size, the better. And it depends on what sort of drug and what sort of illness as well.
Yeah.
I mean, sometimes if it's a very rare condition, actually doing it on 20 people might be quite
Tricky.
big, because it's tricky. If it's a cure for the common cold, well, you should be able to do it a lot more. And if if each pill costs £20,000 because it's brand new, I mean, you're only going to do that on 20 patients if you really think you're going to make a decent profit afterwards. It's all sorts of things sort of will come into here in real life.
Why
That
do
was
you
greater than-
accept H0?
We accept H0 because of what we wrote down here. We only accept H1 if this probability here is smaller than the significance level that we are using. Because it's only if that probability here is smaller than that, we say, well, the chances of it happening through the old drug is very, very small. Okay? Just going to stop recording at this point.